Hello guys, welcome back to Khaliltronics. In today's video we are still in limits under factoring methods. So we are trying to find this set of questions using limit. So actually to find this using factoring or factorizations, you need to follow some procedure. So consider this function. Let's say we are to consider this one. So the f of x we have here is we have x squared negative minus 9 all over x plus 3. So considering this function and our limit is what? X approaches to what? Negative 3. So we have to find this. So consider this function x squared minus 9 all over x plus 3. How will you find the limit of f of x as x approaches to negative 3? If you try to use substitution method to find the limit, will end of Faraday's answers. So since here if we use substitution, limits x approaches toward negative 3. If we use substitution, we will to let x to be equal to negative 3. So we will end with 3 square, here is square, 3 square, then minus 9 all over what? Minus 3 plus 3. So here we have 9 minus 9 all over what? Minus 3 plus 3, which is equal to what? 0 over 0, which is what? 0. So since here is 0, so it's not appropriate, we are not going to use this substitute method. So but fear not, this answer is just tell us we must use different method to find the limit, because the function is likely has a hole at x gives the value. Therefore the factoring method can be tried. To start this method, the numerator and denominator must be factorized, and in this case our denominator is already factorized, so we are gonna look at the numerator to factorize this. So we're gonna proceed with question number 1 using factoring method and solve. So the question 1 is limits as x approaches to negative 3 x squared minus 9 all over x plus what? 3. So if you really carefully, here we have x squared minus 3 squared all over what? X plus 3. So at the numerator here is different of 2 square. When you have a square minus b square is the same as what? A plus b, and then what? A minus b. So we're gonna use this method, this function, as we have x squared minus 3 square. Therefore here can be x plus what? 3 all over what? X minus 3. So it's very simple, we are just substitute. So we can say limit as what? X approaches negative 3 of what? Since our numerator is turned to this, so we can substitute. We can say x plus what? 3. The other one is x minus 3 all over what? At the denominator we have x what? Plus 3. So this one go with this one, so we'll end with what? X minus 3. So limit at x approaches to negative 3 x minus 3. So we're gonna substitute x to be equal to what? Negative 3. So we can say negative 3 minus 3, which is what? Negative 6. So negative 6 is the appropriate answer for this. So we can say our answer for limit at x approaches to what? Negative 3 of what? X squared minus 9 all over what? X plus 3 is equal to what? Minus 6. So we're gonna take the next question, which is what? Question 2, and solve and see how it's gonna be. So So question number 2, let's take question 2. That's question 2. Question 2 is to find the integral limits, as x goes to approaches to 5, then the function is given as 2x square minus 7x minus 15 all over x minus 5. So we are trying to solve this. So as you see, if we substitute x to be equal to 5, we'll end with a product function. So let's see, x into here we have, you can say 5 square minus 7 into 5 minus 15 all over 5 minus 5. So here we have 25. 5 square, 25 times 2, which is 50. Here we have 7 times 5, which is 35. Here we have minus 15. So here we'll end with 50 minus 50. At the denominator we have 5 minus 5, which is 0 over 0. So using substitution method, you are not going to get appropriate answer. So we have to factorize both denominator and numerator also. Similarly, at the same procedure at the one that we have solved in the above. So already the denominator is factorized, so our focus is on the numerator. So we are to express this, we are to factorize this minus 15. So we have to get two numbers such that when you multiply it will give you the middle term. When you add off, it will give you the middle term. When you multiply, it will give you the third term. So the coefficient of x square has coefficient, so multiply by the constant term, which is c. You can say AC. So you can say 2 times 15, we have negative 30. So we have to get two numbers. The two numbers that can give us when we add off, it can give us 7. So the number are 10 and 3. So let's use sign. Here we have, if you see, the number is 10 and 3. So if you say minus 10 plus 3, it will give us 7. So the number is 10 and 3. So we can say we have 10, since it's 10 minus 10 and plus 3, we can say 2x here is square, 2x square minus 10x minus 3x minus 15. Here is positive, plus, yes, here is minus 15. So to factorize this also, we can factor out 2x square since it's common. So you can say 2x square out, remain x minus 5, and then the other one is 3 outside, which is x minus 5. Here is x minus 5 here. So since the both 2 is common, we can take one. We can say 2x plus 3. The other one is x minus 5. So this is the factor of the numerator. So we have limit as x goes to 5 approaches 5. So we can say we have the upper one, that's at the bottom, we have 2x plus 3, and the other one is x minus 5. At denominator we have x minus 5. So this go with this. Then we have limit as x code 5 goes to 5. Here we have 2x plus 3. So we have to substitute x to be equal to 5. So we can have 2 into 5 plus 3, which is 10 plus 3, which is approximately equal to 13. So we're gonna take the last question and solve. So the last question, that's question 3. Question 3, the question is to find limit as x approaches to 1 x cube minus 1 all over x minus 1. x cubed minus 1 all over what x minus what 1. So the question is here, we are trying to, so the question is, this is given as to find the limit as x approaches to positive 1. So likewise, if we substitute x to be equal to what 1, we'll also end with Faraday's function, which is what we can see, 1 cubed minus 1 all over 1 minus 1, which is what 0 over 0. So we are not going to use substitution method. Also, this is what you can solve this one using factoring method. So to do this, you can get a 2 factors which will give you this. So how can you make this to factorize s cubed minus 1? So basically, using binomial theorem, you can have something like this. Let's say if you know, if it's what difference of 2 square, let's say if you have this is equal to what x plus 1 into what x plus negative x minus 1. So likewise for this, you also have x minus 1, and the other factors, how can you make it? So you can say, let's say you have this x plus 1, so how can you make it to be this? So and see which one am I going to add. Firstly, you have to make such this negative x minus 1 x plus 1. So how can you make this one to be arrived as this, to let it be equal to x cubed minus 1? So by adding something here, so if you add x, so we can say, let's say if you add x, so if we add x, we can say x here, x square, another here is x, so it's not going to give us x cubed. So but what if we add x square here? So we can say x times x, we have what x cubed, and then if we say this times this, here we have what x square, negative x square. And then if we say this one times this, here this one times this one is x square, plus this one times this is positive x, and this one times this plus x. This one times this is what is just x square, negative x square, and this one times x is just what x, negative x, and minus 1 times positive 1 is just negative 1. So from here, this one go with this one, and also this one go with this one. So we'll end with x cubed minus 1, which is what x cubed minus 1. So this one is equal to this, so we can take this one. Since x cubed minus 1 is equal to what x minus 1 into what x square plus x plus 1, we can take this one in place instead of x cubed minus 1. So we can say limit at what x approaches to what 1 of what x cubed minus 1 all over what x minus 1. So which is what limit x approaches to what 1 of what x minus 1 into what x square plus x plus 1 all over what x minus 1. So x minus 1 goes x minus 1. We will end with what limit at x goes to 1 of what x square plus what x plus 1. So we have to substitute x to be equal to 1, which is what 1 square plus 1 plus what 1, which is equal to what 3. So 1 plus 1 plus 1 is going to give us what 3. So this is how to solve any kind of question using factorization. Just try to factorize the numerator, the denominator at the same time, and then if the numerator is already factorized, try to factorize the numerator, if and vice versa. So after factorization, try to cancel one of the terms and then solve for the value of x and then find the limits. So this is how to solve using factorization. Don't forget to give a like, comment, and also hit on bell icon. If you want to watch the previous video, you can go to our playlist on our WhatsApp, on our YouTube main sites. So thank you for watching. See you in the next video.